All right, let's dive into a piece of tech that's completely changing the game in battlefield surveillance, the Tata Rajak ULRS. We're going to break down its long-range reconnaissance capabilities and all the advanced features that really give it that critical edge out in the field. So, I want you to just imagine something for a second. Picture a surveillance system that doesn't just see, it absolutely dominates the landscape from kilometers away. I'm talking about flawless vision, even if you're looking through a sandstorm, thick smoke, or in total darkness. And get this, what if you could control that entire system from a safe spot, miles away, just over a network? Well, that's exactly the kind of power we're talking about with the ULRS. Okay, so what is this thing really? The Tata Rajak ULRS, that stands for Upgraded Long Range System, is basically a multi-purpose reconnaissance and observation system. It's made by Tata Advanced Systems Limited, and its whole purpose is to deliver near real-time video. And we're not just talking about grainy pictures here. This is all about high-performance live surveillance. One of the coolest things about the ULRC is that it's got this dual personality, First, you've got portable mode. It's lightweight, you can carry it around for quick situational awareness right there in the field. But its real strength, that's in the remotely operated mode. You mount this beast on a tripod with a pan-tilt unit, and suddenly an operator can control every single move, panning, tilting, zooming, all from a safe distance, just using an IP network. That's where it truly shines. So we've seen what it does on the outside, now let's take a look inside. We're going to deconstruct the multi-sensor housing and see where all that incredible power really comes from. Just look at the amount of tech packed into this one rugged box. It's incredible. To nail targets at extreme distances, you've got a mid-wave infrared detector, that's for your thermal imaging. Then there's a day sensor for crisp, high-res video. You've got an eye-safe laser rangefinder, a digital magnetic compass, and a GPS receiver. Oh, and you can even add on a shortwave infrared camera for more specialized tasks. All of these sensors work together to paint a really complete picture of whatever's out there. Now, obviously, having all those fancy sensors is useless without some top-tier optics, right? The ULRS has a seriously long-range, high focal length lens, but the real game changer here is the continuous zoom. What does that mean for an operator? Well, it means you never lose sight of your target. As you zoom in, the image stays perfectly sharp and focused. You don't get that annoying jump where you have to find the target all over again. And believe me, in the field, that's a massive advantage. Okay. So powerful lenses and sensors are one thing, but the ULRS also has the smarts to back it up. Let's get into the brains behind the brawn and look at the intelligent features that make this thing truly advanced. First off, let's talk about its ability to punch right through the environment. It gives you incredible visibility in conditions that would just blind other systems. I'm talking dirt, nasty dust storms, thick smoke, even pitch black darkness. This is exactly where that mid-wave IR sensor becomes your best friend. All right, this next feature is absolutely critical. The ULRS needs zero calibration in the field. Get this, all the sensors, the day camera, the thermal one, the laser, they're all perfectly aligned at the factory. It's a process called factory bore sighting. Now, for the person using it, this is huge. What that means is you don't waste any time fiddling with complex adjustments. You just deploy it, and you can trust 100% that your crosshairs and your laser are pointing at the exact same spot. And the smarts don't stop there. You've also got a ton of visual processing and connectivity features. For example, it can automatically stitch together panoramas for a wider view. It can give you dual video feeds. It's even got built-in defogging and image stabilization, which you absolutely need to keep a steady picture when you're zoomed way in. And, of course, it's built for the modern digital battlefield, so it uses wireless radios and optical fiber cable to send all that crucial data back to command. So let's put all these pieces together and see how it works in the real world. Imagine a surveillance team. They're watching a valley that's known for sudden dust storms. Okay, step 1. They deploy the ULRS on a ridge using its pan-tilt mount. Step 2, they're controlling it remotely from a command vehicle, a safe 500 meters away. Then, just as they feared, a dust storm rolls in. No problem. Step 3, they just switch to the mid-wave IR sensor and cut right through the dust. Step 4, they spot a vehicle on the move and track it perfectly with that smooth, continuous zoom. And finally, step 5, thanks to that factory bore sighting, they get instant, stable coordinates with a single click of the laser rangefinder. See? It's a completely seamless system with every part working in perfect harmony. All right, to really get a feel for what makes the ULRS so special, let's put it head-to-head with another system called the SHRUST. This table really lays it all out. So, on one hand, you have the SHRUST, Think of it like a pair of super advanced binoculars. It's handheld, it's portable, and you control it manually. But on the other hand, you have the Tata Rajak ULRS. This is built for long-range remote surveillance. You mount it on a motorized tripod, and you control it over an IP network. The big differences are pretty obvious, right? Remote control, that factory bore sighting we talked about, the high-end continuous zoom lens, and all that advanced connectivity. They're really just different tools for completely different jobs. Okay, let's boil all of this down to the absolute essentials. If you're studying for an exam or just need a quick refresher, this is the part you'll want to pay close attention to. These are the key takeaways for mastery. Here's a really simple way to remember how the whole ULRS system fits together. Perfect for drawing a quick diagram. First, draw a circle in the middle for the ULRS sensor housing. Inside that circle, just list the key sensors: day, IR, LRF, GPS, and DMC. From there, draw a line down to a little tripod icon and label it pan tilt. Next, draw a line out to a cloud and call it IP network/OFC. And for the final step, draw one last line to a computer screen icon and label it remote operator. Boom! That one simple drawing shows you the entire system. Integrated, remotely controlled, and fully networked. All right, time for a super quick 1-minute recap of the most important points. Let's go. What is the system? It's a long-range, multi-sensor recon tool. What are the sensors? It combines IR, day, LRF, GPS, and DMC. The optics? High focal length with continuous zoom. The big advantage? No need for field bore sighting, and it sees right through smoke and dust. And the tech? It's all about remote operation over IP with stabilization and panorama features. And that, right there, is the ULRS in a nutshell. So, to wrap things up, I'm going to leave you with a question to think about. We talked a lot about it, but why is factory bore sighting such an absolute game changer for a system like the ULRS, which is designed to be operated from far away? Really think about what that means for an operator's confidence and for the overall speed and success of a mission. It's something worth mulling over. Thanks for tuning in.